Alright, today we're going through the first part of the second unit, which is on compositions and inverses of functions. This is composition of functions because I'm still bored. So first of all, what is a composition of functions? So a composition of functions, let's say f of x and g of x, is going to be f of g of x or g of f of x. So what does that mean? Well, basically, if we have a composition of functions, we take the output of one function and use it as the input of another. So if we think about it like a machine, right? If this is our machine, f of x, and we put something through here, the idea of a composition of functions is that this output of f of x is going to be immediately used as the input for g of x. And when you're writing, like when you have two functions and you're trying to compose them, we're just replace one of the functions x's with the other function and then simplify. So what do I mean by that? Well, let's get some practice. So let's say that f of x is going to be equal to 3x minus 5, and g of x is going to be equal to x squared. And h of x is g of f of x, right? Write h of x and then find h of negative 2 and h of 5. So I'm going to give you a minute to try to figure that out, and then I'll... Okay, so h of x, right, is g of f of x. And because g of x is x squared and f of x is 3x minus 5, what h of x really is 3x minus 5, which is f of x, squared, because the squared is the entirety of the g of x function. And then if we simplify this out, if we FOIL, right, first terms, 3x times 3x is going to be 9x squared. Outer terms is going to be 3x minus 5 minus 15. Inner terms is going to be minus 5 times 3x, which is negative 15x. So we get negative 15x twice, or negative 30x. And then last term is going to be negative 5 times negative 5, which is 25. And now you can try to find h of negative 2, and then get back to me. Okay, so if h of x is 9x squared minus 30x plus 25, right, then h of negative 2 is going to be 9 times negative 2 squared minus 30 times negative 2 plus 25, which is going to be 9 times 4 plus 30 times 2 plus 25, or 36 plus 60 plus 25, which is 120, right, because we're just plugging this in for the quadratic. And then h of 5 is going to be the same thing, but we're going to plug in 5. So we got 9 times 5 squared minus 30 times 5 plus 25. So that's going to be 9 times 25 minus 150 plus 25, which is going to be 170 minus 150 plus 25. It's going to be 50. Okay, so what if we already have a composition of functions and we're asked to find the two functions that it is composed of? So if that's the case, what we're really going to want to do is, first of all, there's going to be more than one right answer, right? Because if we have, for example, let's say we have 2x minus 5, and this is in a square root, right? If we have this function, and this is the composition, then the two functions could be 2 of x minus 5 and then the square root of x. It could be the square root of x minus 5 and then the other one is 2x. So it can be multiple of them. But when we're trying to find an example of one, what a good strategy is to take a segment of one of the functions that contains an x and then make that one of the functions. So for example, if we have 2x as our segment, then one of our functions is going to be 2x, and then the other function is going to be x minus 5, or the square root of x minus 5. Okay, so let's do some practice. So let's say we have this function h of x, which is a composition of g of f of x, and it's equal to 2 times the square root of x minus 5 over 3. So there are a couple right answers here, so just pause the video, see which one see if you can figure out what it is, and then get back. Okay, so I got 3 right answers. There are probably more, but these are just all the ones I thought of off the top of my head. So it's important to note that in here, g is the outer function, so we're going to want to take f of x as the little segment, right? So what if our little segment is just this bit, x minus 5? Well, then f of x is going to be x minus 5, so we can see that down here. And then we're going to have to replace this with x to find g of x. And so that's going to be 2 times the square root of x over 3, which is what we have right here. So that's right. Now, what if we have, what if our f of x, what if our little segment that we choose is actually the square root of x minus 5? So in this case, we're going to replace this entire thing with x for g of x. So first of all, if it's square root of x minus 5, we're doing this one, right? And if we're replacing this with x, we're going to get 2 times x over 3, which is what we have here. So this one's correct. Now, what if we have just the entire numerator as our little segment? So that will be right here for f of x. And then if this is x, then all g of x is going to be is x over 3, which we have. Alright, so these 3 look good. So what would be an example of something that doesn't look good? Because we already said that it can be a lot of different things, so it can be hard to tell if what you got is correct or not. Well, if we have this, for example, if we have f of x is equal to is square root of x minus 5, x minus 5, you might be tempted to put, just for g of x, you might be tempted to put 2 over 3. But this isn't right, because both functions need to contain an x. Because if we're plugging f of x into g of x, and there's no x in g of x, then there's nowhere for us to plug it in, right? So this has to be 2 times x over 3. So yeah, that's composition of functions. Bye.